So we're looking at logarithms, which are the opposite of exponentials. Basically, they undo each other. So up the top there, I have an exponential. A to the power of b is equal to y. Well, I could also do the inverse of that. The log of a of the value of y is equal to b. So the question is, the log, what power do I need to raise a to so that I can get to the value b? So if we think about it like this, log 10 of 100. What do I have to raise 10 to the power of so that I get the value of 100? 2, correct. So if I was to rewrite it the same way I've written this one, well, that would clearly be 10 to the power of 2 is equal to 100. Now, the thing is that this works for even weird numbers. So, for example, if I wanted to work out, okay, log 10 of 300. All right, I can use my CAS to do that. So let's turn on the CAS. There's me doing some other stuff. Now on the keyboard, which doesn't quite work on the screen here, when you press the keyboard button under Math 1, you will see two buttons. One looks like this, log one looks like that. And then another looks like log 10 bracket all right, so these are our log buttons. Log blank blank is for if we want to find something else, and I'll show you how to use that in a moment. But for now, to solve the problem that I've got above me, so log 10 of 300, I can put in my CAS, I can find the log 10 button, and then just type 300. And it will give me the answer, 2.477, etc. So, if I was raising 10 to the power of 2.477, then that answer would be 300. So logs can also be used as a way of solving equations. If I, for example, had two to the power of x is equal to 200. And I need to figure out what value I'm going to use for x. How am I going to find that? Because clearly me just putting it in one by one isn't going to help. But what I can do is use my knowledge of log laws to simplify this process. If I have the log of a to the power of b equals whatever, what actually happens to that b is that b actually falls out the front. It's a rule. Lets me simplify this log. So what I can then do with the one above is go, okay, log 10 of 2 to the x is equal to log 10 of 200. Because anything I do to the left-hand side, I do to the right-hand side. Then, from there, I can use this law above here to simplify what I've got here. X comes down the front, and I'm left with log of 2 equals all right. Now, whenever you see someone write a log, if it's just log by itself and they don't write a number, assume it's 10. All right. Otherwise they'll tell you what it is. And then log 10 of 2 is a number. It's a complicated number, but it's a number, and we can divide both sides to solve it. So I can then go, okay, we'll divide both sides by log 2, and I can get the answer of x equals log 10 of 200 divided by log 10 of 2. And then my calculator, will give me a value. Give me an answer of 7.643856619. And I can try that by going 2 to the power of answer, and it comes out as 200. But the other thing I can do is I don't have to use log 10. I can use logs of other numbers. So for example, I could talk about, well, log 3 of 27. Is question mark. I could do it like that. Like, so this question is asking 3 to the power of what equals 27. And our CAS can do that. So by using the other log button that has the 2 shaded boxes, like so behind me, I can put 3 down in the bottom, and I can put 27 inside, and it will tell me the answer is 3. So 3 to the power of 3 is 27. And I can use that to manipulate and solve things. So I could actually go back and solve some of the other problems easier. Because one of the things to remember is, what is log 10 of 10? It's 1, because 10 to the power of 1 is just 10. If I do log 3 to the power of 3, what is it? Log 3 of 3. It's still 1. All right? And so forth. If I take the log and the base and the number are the same, then the answer is just 1. So I could, in fact, go back to my previous question and do log 2 of 2x equals log 2 of 200. The x would fall down the front, and I would have x log 2 of 2 equals log 2 of 200. What's log 2 of 2? It's 1. Therefore, I don't need it. So I now know that the exact answer that I want, is just x is equal to log 2 of 200. And then I can put that into my calculator. And it comes out the same answer as what we had before. You can see it above. Where this gets more applicable is when we start looking at the graphs of these things. That's all right, thank you. So let's go back to our CAS. And we'll go to table and graph. We'll get rid of our exponentials from the other day. And let's look at log graphs. All right, so oh, hang on. Let's move that over there and that behind me. Actually, that can just go away. I don't need that right now. Nope, that one. All right, so what I've got there is my CAS, and I've drawn the graph of log 10 of x. And the graph looks like this, which is what we've got. So we can have a look here and see this graph. It starts, where does it start? Let's go all the way back to 0. So at 0, the graph is undefined. Because remember that 10 to the power of something can never ever equal 0. X cannot equal 0. So we have a firm, hard asymptote. All right, so it is asymptotic because, you know, we could have x equals 0.000000001 and you would still have a value. You could have, you know, infinite number of zeros. All right, so from that point, it's literally just straight down. And then the graph ramps up So it's quite extreme over here, but it's quite flat over here, which is kind of like the opposite of another graph that we know, or that we've looked at. So these two graphs are effectively the inverse of each other. They are the polar opposites. This graph here starts very, very steep and then gets very, very flat over here. The other one is the other way around. It starts very, very steep and then flattens out. They are inverse functions of each other. But like all good graphs, we can change them. By changing the numbers that we've got in front of it. I can do things like dilate them and stretch them. I can put a negative in and flip them. I can put a negative on the inside of the brackets and get them to move around like that. So it's almost like they're a square root graph, but they're not. They have a different shape. All right, so I can dilate it in multiple directions with the number at the front here and the number in front of the X, and then I can move the whole thing up and down with these other values as well. All right, so we've got a few different ways that we can play around okay. So what your job is today is you've got a number of questions, selected questions from 13E and 13G that are around using your CAS to play with some of this stuff. We're going to take a further look at doing algebraic solving using logarithms when we get back on site, but for now, we're just playing with our CAS and we're doing simple graphs and drawings. All right, if you need to practice or you need assistance in drawing them, make sure that you get it up on your CAS screen first and draw a table of values. And what you can also do is, remember, your CAS can also generate that table of values for you. If you press this button here, obviously depending on which equation that you're using, so for example, if I was using, if I went up in here and I just did log 10 of x, and I put that in, I do a table of values, it will tell me what I need to know, and then I can change it and get it to say go to 50, and it will give me the values that I need, and it will just generate everything I need to help me draw that graph precisely.